Hello everyone. So now that we've seen the basic way to set up sockets for a client, I want to show you a way to do this that's a little bit more modern and that is more flexible so that you don't necessarily have to say, okay, I'm going to use IPv4, maybe IPv6 is the better option. And the other thing is we don't always know what the IP address is of the server that we want to connect to. Sometimes we got to make calls to DNS in the background. So I'll show you how to do both of these things kind of in the same paradigm here. So what we need to do is set up this struct with information, just like we did before, but we're going to pass it to a different method called getaddrinfo. All right, so let me look at that method in the man pages here, getaddrinfo. So when I look at this, okay, first of all, got to make sure I got the right include files here. So if I look up here, I've got, okay, I'm going to need to include this. I don't have this yet. And then netdb.h. Okay, so let me put these three in here. I've already got socket, but I'll just put those there. Okay, so looking back at the documentation, this getaddrinfo method that's going to help us out takes 4 parameters. The first one is node. And if you look at the documentation, node is for an internet host, which does not just have to be an IP address. This can be a general domain name, and then the domain name system, DNS, will work in the background to get us an IP address. But here we can be more general. So here I will say, all right, let me start setting up my call here. Let's try Google. Why not? Getaddrinfo, www.google.com. And that should eventually give me an IP address in the background. The next parameter is service, and for our purposes here, this is going to be a string with a port number. So I'll use 80 because I want to see what Google's HTTP server gives us. All right, now jumping back into the documentation again, I see that the third parameter is a struct called address or addrinfo. And if I look a little further down in the documentation, I see this is a whole lot of information about a particular connection. And in this context here, what we're going to use it for is to give this method some hints, some preferences on the kind of connection that we want to establish. So what I'll do is I'll go ahead and I'll define a struct like that. I'll say struct addrinfo hints. Now there is unfortunately, I used the variable name down here for something different, but yeah, this is the name of the struct that goes with this method. And so I can specify as many preferences as I want. The ones that are left blank are treated as variables that this method is going to figure out what works. I'm only going to tell it 2 things for now. So I'll say, if I look back at the documentation, let me specify AI family. That's going to be the kind of IP address in this case that I want to be able to get. So I'm going to say here, okay, hints.ai family equals AF unspec. So before I was using IPv4, I said AF inet, but here I can leave it unspecified. So I'll say use either IPv4 or IPv6. So I know I want it to be an internet protocol, so I'm looking for some kind of IP address, but I don't care which one it is. All right. I can also tell it, I'll look back at the documentation, I can also tell it what kind of socket I want to use. And so here I'm going to use TCP again. So I'll say hints, I'll narrow it down that far. So I'll say AI sock type equals sock stream. So I've already done that in another context. And those are the only 2 things I'm going to specify. So I'll say, yeah, I want to use TCP, but you can use either IPv4 or IPv6. And let me just pass this along by reference. So I'll pass along a pointer to this. And do your thing. See if you can find, an IPv4 address that works, an IPv6 address that works with the TCP socket. All right, but if I look at what this returns, what this method returns, it returns kind of like a lot of other these system calls that we have. It returns 0 if it succeeds or an error code if it fails. So what I'll do here is I'll say, okay, int return. I'll say if return is not equal to 0, then I'll print it to standard out what the problem was. Whoop, I meant to say, yeah. So I'll say, okay, look, error number blah, getting address info. And I'll exit the program, so I won't keep going. Okay, so that's what it returns, but that's actually not, like if it worked, great, it returns 0. That's not really super useful. What I'm looking for here is a lot more information about what I need to open a connection to the host that I'm trying to get to. So I need actually another one of these structs that has all this information. And really what I'd like to know are things like, well, what's the address? What's the actual IP address that I'm connecting to? Now, what's going to happen is this is actually going to, by reference, return a linked list of possibilities, okay? Because there may be more than one thing that works. So this fourth parameter is for passing a pointer to an address that's going to hold the head of a linked list of possible, because we don't know how many different configurations we could use that adhere to the parameters that we set here. We need a flexible way of returning a bunch of them. So I'm going to call it exactly what I would call it. And the other linked list that I made, I'm going to say, all right, I want a pointer to one of these called node. And I'm going to pass that as a parameter here, a pointer to that. And so it'll fill in the address of this with the address of the first struct that has a valid configuration that we can try. So that's the beginning. That's like the head of the linked list. And you notice actually there's in this struct there's an AI next, so we can keep walking through the linked list. So actually, let me keep this over here for a second because I want to look at these fields, and I'm going to try to loop through and see, like, okay, what is it actually giving me here? So let me just comment out all this stuff here for a second, what I was doing before. We'll update it momentarily, but let me just loop through the linked list first. So I'm going to do that standard thing. I'll say, okay, while node is not null, right? While I haven't reached the end of the linked list, I'm going to keep going. So I keep going by saying node is equal to node. In this case, they call it AI next. Address info next, I guess. But in the meantime, I can print out some information. So I'll say, okay, let's print out, maybe I'll print out the AI family that it chose. So I'll say AI family equals blah. And then I'll print out the socket type, AI sock type. So these should be, let me actually just print a little thing to help me. So I'll say AF inet, so this would be IPv4. I need to know what number that actually is to make sense of this. And then I'll also say AF, the one for IPv6, I think is inet 6. Let me see, inet 6. Yeah, AF inet 6. So we'll see what those numbers are, and we'll try to match them up here. And then let me also print out what sock stream is, what that number is. Okay, you can probably look these up somewhere, but I'm just going to print them out right now. Okay, cool. So I'm going to print out that stuff. And, okay, I'll start with that. So I'm going to print out here node AI family, node AI sock type. And let's see what it gave us, all right? I said I wanted to connect to google.com on port 80. How many different ways can I do that adhering to these specifications? So let me just make this real quick. I need a semicolon somewhere. When I was printing, I forgot to put a semicolon. That was a long line. Okay, let's try this again. I said exist instead of exit. You probably noticed that already. All right, so let's run this. ADDR client. And, oh, it would probably help if I put a line break after some of this stuff. So I'll do that there. And finally, let's get this here. Boom. Okay. So there are two different ways of fulfilling my request. One is by using apparently IPv4 with sock stream. So we see sock stream as one. And another one is by using IPv6 with sock stream TCP. So that is great. We have two options. We can just choose one of them. All right, I had to go teach my music class and switch locations, but let's finish this up now because we're almost there. So I want to show you, in addition to these parameters that I'm printing here, there are a lot of other things that are packed into the struct that's being returned from getaddrinfo. And one of them is the actual IP address of the possible connection. So this is what the domain name system would return. So I want to try to print this information out, if I can. And I'm going to do the reverse of what I did in the last video. So this is already going to be in binary format, but I want to convert it to a human printable format. So let me just jot down really quickly that this is the variable that I want to get at here to print some information about each of these connections. And then what I want to do is, if you remember, I used this method last time called, let's see, where is it here? PTON. Okay, inet PTON. So this was a method to convert a human readable IP address into a binary format. And I'm basically going to do the reverse here. So I'm going to use inet N2P if it's a IPv4 address, and I guess there's another. So let me look this up. Inet N2P. There should be another one for IPv6. Okay, so this is, actually both IPv4 and IPv6. Okay. So if I look at the documentation here, I just have to kind of do the same thing I did before. So I'll just copy and paste this in here so I have this I can look at. So first I need to see, is it an IPv4 or IPv6 address, and that's going to change how I use this method. So that, I think, is this first parameter here. So AF is, let me just check, AF, yeah, address family. Okay. So yeah, I'll make sure the first parameter is whatever, in fact, node AI family was, so that'll either be IPv4 or IPv6. And then this is going to be a pointer to the data that's holding the binary information. And then this destination is going to be a pointer to the human readable string. So let me make here, I'll say char IP. I'll make it bigger than it needs to be, maybe 32 characters. So I'll put that in here, IP, and that's just, this should be how many bytes I can write up to into this human readable thing. Yep, okay, so I'll just put 32 there. Okay, so the last parameter I need to get in here is a pointer to the binary data for the IP address. And this is contained in this part of the node, but it's actually packed in an interesting way. So actually, let me get this pointer back here. So I gotta look at the documentation for sock addressed to show you what I mean. So if I look at man sock addr, this is actually a generic struct for storing different types of address information. And so it tells, all of the structs will start off indicating what kind they are, but then there's a variable number of parameters that come after that. And so this is actually just generic binary data, and it needs to be cast properly to interpret it. So if I cast this as a sock address in, it's going to have these parameters. If I cast it as a sock address in 6, it's going to have these parameters. Now, what's interesting is there's actually more binary data I need to store to represent this. So this generic structure has enough padding to encompass both this and this. Okay, so this is a big enough to hold any kind of address, but not all of the binary data ends up getting used in this one. Okay, but I need to know how to cast it before I can get to the info that I actually want, which is the binary info for the IP address. Like, in this case, it would be this, and in this case, it would be this. So let me go ahead and do that. So based on what kind of address this is, so I'll say node AI family. If that is IPv4, so I'll say if that is AF inet, then I'm going to cast this as a sock address in. Okay. So I'll say struct sock address in pointer. I guess I'll just call it IP data. So that's going to be struct sock address in pointer of node. So the generic structure that's in here, AI addr. Okay, so we're almost done. So I'm gonna have to do something different for IPv6. I'll hold off on that for a moment. Let me just see if I can get this right first. So I'll call this method, and what I gotta pass along here is, okay, once I've cast this properly, I look at this and I need to drill down into this thing, inaddr. And I've done something like that already down here in the example I gave you before. And within that, there's actually another field I need to drill into, which I'm not sure if I actually have to go that far, because I think there's only one field in the struct at that point. But yeah, let's just see here. So if I were to say, okay, so I've cast that, and then the thing I need to pass along is IP data, sinit address, and then dot that. And it's expecting a pointer to that. Woo, okay, so this is really going to test your pointer knowledge to make sure that you get this right. Let's see if I even got this right here. Let me try to compile this. Okay, it compiled. So let me just print out this information if it worked. So I'll just pass along whatever string that it converted it to here. Otherwise, I really should say else if node AI family equals AF inet6. I'll deal with that in a second. But for now, I'll just print a line break. Okay, so let's compile this and see. Is it going to work? ADDR client. Ooh, it says error number -2 getting address info. That's interesting. So what is error number -2? Okay, so I noodled around for a second. I realized I did something a little silly with hints here. So one thing we got to be really careful about is when we declare variables on the stack in C, they might pick up random data in memory. So we got to make sure that we kind of initialize them and zero out things that we want to zero out. So what I'm going to do is, so I set these parameters, but there might be other parameters of this that just got random values and it's freaking out. So I have to say memset. I want to go to the address where this is in memory, hints, and make everything there 0 first. Struct addrinfo. Okay. So man, the devil is in the details when you're programming in C. Okay. But yeah, so now let me compile this and run this. And beautiful, I actually get something here. Finally, I was able to decode the IP address for IPv4. So let me just check this real quick. If I put this IP address into my browser, so this is supposed to be for google.com if you remember all the way back to the beginning. There we go. Now what's interesting is if I run this multiple times, well, it's not happening here, but I may actually get different IP addresses. The domain name system will give me different IP addresses because Google has tons of servers. Okay, so I can finish this up for inet6 here if I want to. I'll just do that. It's the same thing. I'll just pause the video for a second and complete that code. Okay, so here's the code. And also, like I said before, I don't actually need to drill all the way down for either of these. If I look at the documentation here, I see that in address and in 6 address each just have one field. So the memory address at the beginning of this struct is the same as the memory address of the beginning of the data that actually holds the binary data that I'm looking for. Okay, so let me just compile this and make sure it runs real quick. Okay, and actually we got a different IP address this time. Enough time has elapsed. I guess the domain name system gave me something else from where I am. But here's the IPv6 address. So there you go. Now, what's this all useful for? So I did a lot here. First of all, it's just kind of cool to be able to run the domain name system from C and get a human readable IP address. That's really, that's a big accomplishment already that we've done. But ultimately, we want to use this information to make a connection. So we want to set up a socket on one of these types of connections that we've made here. So what I'll do is now kind of put the code that I wrote before up here. And so, yeah, I'll get rid of this. We don't really need this anymore. This is just telling me what these magic numbers were, but I know what they are now. So what I'll do is I'll declare this sockfd before, but I'll make it -1. And what I'll do is I'll try, every time I see one of these connections, I'll see if I'm able to connect. So I'll say, okay, let me try to make a call to the socket system call with the proper family, the proper
connection type here, so I'll say, or socket type node AI sock type. And also, I don't necessarily have to make the last parameter 0 because that is also a thing that's returned from in this address info. So I say man ADR info. Whoop. I'm going to say man get address info. I see actually this last parameter to the socket system call AI protocol comes through too. So it's probably 0 for these examples, but just to be safe, I'll say node AI protocol as well. So what I'm going to do here is check. I'm going to try to make the socket, and what I can do is I'll say if I succeeded, if sockfd is not equal to -1, then I'll break out of the loop. Okay. But otherwise, I got to continue. I got to continue on and try another option. So it's like, okay, I tried to make a socket with this, but if it gave me a -1, then I'm out of luck. I need to try another one of the configurations that they gave me. Okay? But so that's how I open up the socket. So rather than saying explicitly before, okay, here's the configuration I want to use for the socket, instead I'm going to use one of the configurations that I got here, try to open up a socket, and if I was successful, then I'm going to keep going, and now I don't actually have to do any of this crap because I already have the information that the domain name service gave me about the port and well, I mean, I passed the port as one of the hints, but yeah, that's all encapsulated in this address info that I already have. So I can just say node. I already forgot what it was. It was yeah, AI ADDR, right. So I don't have to do any of that stuff that I had to do before. I'm just going to use whatever I mean, honestly, me just printing this out was just to show you that it made sense. But you usually don't even need to print it out. You just pass it right to the connection thing here. But yeah, I guess, okay, there is actually one more parameter here. I need to know what the size of it is, and that should be here. I think that's this. Yeah, AI ADDR len. Okay. So back down to where I was. I'll say node AI ADDR len. Okay, so basically the same code I had before, except, I made the domain name system do the hard work of finding the information that I needed about the IP address. Okay, so let's just compile this and make sure it runs. Always want to do that as often as possible. So, okay, it runs. It was able to send these bytes over the wire, and that's cool. But what is Google going to do for me? I'm sending Google information. So let's try to receive some bytes back. And that's very similar to the send method. It's called RECV. You can look at the documentation. But basically what I have to do is send, the first parameter is the socket descriptor. And then actually the parameters are exactly the same, it's just coming the other direction. So what I'll do is I'll set up a buffer to receive some information. So maybe I'll go up here and define, I'll say define buff len, maybe I'll say 1024 bytes. And okay, and then I'll make a buffer that's big enough to hold that. So I'll say char buff len. So I'll pass that along, buff len. And then the last parameter here is flags. I'm not going to do anything special with receive now. I'm just going to do that. But I should keep track of how many bytes I actually got back. All right. So let me go ahead and print that out. So I'll say blank bytes received. And then I'll print out what, in a human readable format, what the string actually was that came back. So I'll say buff. Now if I run this, something interesting is going to happen. It actually freezes. And the reason is, with the HTTP protocol, so we've connected on port 80 here, it's waiting for me to send more data because in its header, it's expecting me to put a /n, or it's either /n/r/r, I think it's /r/n, two of those in a row. And then it knows that it's done the header. Let me check this. Okay, so this time it actually finished because I sent it in the HTTP header. It's waiting for this. The server is getting information. It's waiting until it sees this until it sends me a response. What it tells me here is, actually, it looks like it's sending me an error web page. Bad request! Exclamation mark. And actually, I didn't quite get the entire web page here. If you look, it cut off. And so what I would have to do in practice is read in a loop. I would have to keep receiving until I knew that I was finished. And one question that you might ask is, well, how do I know that I'm finished? And you don't actually know unless you've established a protocol ahead of time, or unless the sender closes the connection. But this is why you need to know, like in the HTTP protocol, there are different ways of indicating how many bytes you're about to receive. If you're developing your own protocol, you need to indicate that somehow, because I really don't know how many bytes that I'm going to receive, so I really need to be doing this in a loop. And so I'll have you do that on homework too. Okay? But anyway, so for now, this concludes the gory details of getting an IP address associated to some host, and then doing what we did before, establishing a client connection. All right? And I was very careful the whole time to check all the error messages. Very important. You don't want to keep going unless you know that these system calls have been successful. Very important with this complicated system here. But if you get it right and you're lucky, then you'll be able to actually communicate over a network. All right. So that's it for now. Oops, I realized one little mistake I made here. This is not quite big enough to hold all IPv6 addresses. So IPv6 is it's 128 bits, which amounts to 16 bytes, and they're grouped by 4 hex or 4 bytes at a time, which amounts to okay. So 16 bytes is 32 hex digits, and they're grouped by 4 bytes separated by colons. So that means actually grouped by 8 hex digits. So there's 8 groupings which are separated by 7 colons. So 32 hex digits max plus 7 colons. That would actually be 39 is the maximum IPv6 address length. So let me put in 40 here just because that can also hold the null terminator. So 40 is big enough to hold all possible addresses. Okay, so sorry for messing that up, but here we have it now.